How y'all doing? It's Mr. Gelber here again. I have notes. I need to reference notes for this topic, and the topic is viruses and infectious stuff. Things that could get us sick. Terms you might hear while we're going through this COVID corona experience and have to do distance learning. Pathogens. Pathogens is something you might hear. Pathogens are things that could get you sick, like a virus. And they're typically spread through the air or by contact with someone else's fluids. You could use your imagination what somebody else's fluids are, but think boogers and spit. Boogers and spit, blood. Viruses, they're a pathogen. They're a submicroscopic agent that can infect living cells in plants, animals, and or humans. Now, you could have viruses that could only affect plants. You could have viruses that could be carried in plants and affect animals and humans. You could have viruses that only affect animals. You could have viruses that only affect humans, and any kind of hodgepodge of the mix exists. Viruses are real. Airborne. Airborne or also aerosol. You might hear parents or people talk about aerosol or listen to the news, or if the news is playing in the other room, you might overhear it. Aerosol, what's that mean? We think like hairspray, maybe. I use it every day. Not really, I don't use hairspray, but Aquanet. Hairspray in a can. Aerosol. Pretty much is pathogens that are spread in the air. They're airborne, but they're not really just in the air. They're actually in microscopic little moisture droplets of fluid, like flying through the air, super small. La 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 la. Moisture flying through the air, like humidity. Us here in California, we often don't have much humidity, but where I come from back in New York, we have a lot of humidity. And I'll tell you right now, I don't like humidity. You take a shower, you dry off, you step out of your house, you feel like you just stepped out of the shower all over again. I think it's gross. It's moisture in the air. You're walking through aerosol moisture stuff. Airborne moisture, water. So, if it's airborne, pathogens could spread through itty bitty tiny droplets that are hanging out in the air. And they are sprayed during breathing, coughing, or sneezing. Coughing or sneezing or breathing will put moisture droplets in the air. So when you're all in a room together and you're all inhaling and exhaling and inhaling and exhaling, you're sharing each other's breath. You are essentially sharing other people's moisture, fluids from other people. Kind of gross, but that's the reality that we live in. It's called being human, the human condition. So, the way we could catch a pathogen like a virus is through what we would call a portal of entry. Portals of entry, what could they be? They could be a cut or an abrasion or a little scab that cracked open a little bit, a burn, a pimple, open spot in the skin. That's a portal of entry. But here we get to the really funky stuff. Eyes, portal of entry. Moist eyeballs. Nose, opening, portal of entry. And our mouth. So someone sneezes, whoosh, pathogens are in the air. We walk by. We don't even walk by right during the sneeze. And next thing you know, we get their moisture in our eyeballs. And in that moisture might be a virus, a pathogen that could cause infection. True story. It's real. It happens. Sounds gross. Don't be freaked out by the world, because we've been living in it for how long? It's amazing we've made it this far. So, that's that. Some basic terms. And then there's something called a chain of transmission. Here's where we get a little fancy. The chain of transmission is how a pathogen, such as a virus, is spread. So, there are essentially 6 elements of the chain of transmission. The first one is you have to have an infectious agent, a pathogen. A virus. That's element number one. Element number two is there has to be a reservoir or a source, such as a person, their boogers, their spit. That's the source. My nose is a little runny, not because I have a virus, but because I'm standing outside in the cold. But I'm here because of the chalkboard, and we'll get to that in a minute. So reservoir, that's number two. Number three, portal of exit. So if a person and their spit or their lungs or their boogers are the reservoir, and now all of a sudden they sneeze. The sneeze comes out of their mouth and their nose. That's the portal of exit of said person. Number four, the means of transmission is the force of which it came out from: the sneeze, the cough, the breathing, the spitting, whatever. That's the means of transmission. Portal of exit will be the nose or the mouth, and the sneeze is the means. Yeah, the person is the reservoir or the source of the infectious agent. Portal of entry of said other person. We went over that. Eyes, nose, mouth, cut, pimple, abrasion, any open port into your human body is a portal of entry. And then last but not least is the susceptible, the person who catches it, the host. I'm not going to try to say the word. I'm going to stutter if I do. So the host, the person who catches it. Those are the 6 things. So, I'm walking down the street. I'm all fine and good. Joe Schmo over there sneezes. I walk through it. It goes into my nose or my breathing apparatus, my lungs. And next thing you know, I catch it. I am the new host. My portal of entry was breathing in what they breathed out. The means of transmission was the sneeze. The portal of exit was their nose and mouth. And the pathogen, the issue, is said virus that may get me sick. Hopefully I don't get sick. I've been staying pretty healthy so far. So we're gonna keep that at that, right? So that's pretty much basic 101 stuff there. Moving on. Now, these things have a half-life on surfaces. In recent studies, I read this thing a few days ago, maybe like a week ago, about this research that was actively happening on the current COVID-1, 2, COVID-19, whatever we call it, Corona, however many names we're calling it. They were doing research on its life on surfaces. So I'm just going to share those numbers with you. In the air, an aerosol or a sneeze, 3 hours it will live in the air. On plastic, 72 hours, which is 3 days. On stainless steel, much like a refrigerator, sometimes they're made out of stainless steel, 48 hours, 2 days. On copper, students of mine who have done coppersmithing, I love copper. COV2 is no longer found after 4 hours on copper. COV1 on copper is no longer found viable after 8 hours. Interesting. On cardboard, COV2, 24 hours or 1 day. On cardboard, also COV1, 8 hours. Which is interesting. COV1 lasts 8 hours on both copper and cardboard, last I checked. So forgive me if that is false currently, if it's not currently up to date. Plastic, 72 hours, that's 3 days. That means your case on your phone. You touch a doorknob, you go into a store, you pull out your phone and you start texting. You picked it up from the doorknob, you put it on your phone, you put it in your pocket. Now it's going to be on your phone for 3 days before it dies. Just something to think about. Stainless steel, 2 days, 48 hours. Oh, the door handle to most cars are made out of plastic. 3 days. Copper, COV2, only 4 hours. COV1, 8 hours. It's still a good amount of time, but things aren't covered in copper, so. Cardboard, the package that gets left at your house, 24 hours or 1 day for COV2. COV1, 8 hours. I hope I'm right with that. I hope that one, COV1 on cardboard, is still 8 hours. I don't know. Now, we hear that this thing is like super crazy and super strong and wiping people out all over the world. Well, how is that a thing? You know, and then also soap magically just destroys this supervillain. Well, so soap. How does soap all of a sudden kill a supervillain? It's really interesting how that works. The supervillain like stopped the world almost, you know. There's a lot of good things that are coming out of it, like a lot less pollution in the world currently. The air is really nice, although I live in the foothills and the air is already really nice up here, way better than down in the valley with all the pollution. But anyway, let's talk about this. So this virus thing, a virus, dun, dun, dun. How am I going to draw this thing? So we're going to have this, 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 and this. And then in between that, it's going to be this, this, this. But let's just color that in a little bit. This is supposed to be like a circle. Let's just do it like this. Cut to the chase here. All right. So, I don't know, can you see that picture so well? It's pretty far from the phone, and, well, we're going to have to just roll with it here. So this right here, this spike is a protein spike. This is actually what gets it to stick to us. So, technical terms, is an RNA style virus, I believe. And here, this brown zigzag in the middle, can you see it? Let's make it better. Can you see that now? My head's not in the way. That brown zigzag in the middle right there, that's the genetic makeup. This blue ring, that's a fat, that's a lipid membrane. And these protein spikes are attached together with a lipid membrane. So what happens is when we breathe in this supervillain, we'll call it Corona or COVID or whatever it is, these protein spikes connect to us, and then through that the virus kind of gets taken into our body somehow, and we bring it in through the protein, and then it dumps its genetic material. It's an RNA genetic material, and then we get sick. That's how it happens. But there's a lipid layer that holds those proteins together. That blue. That blue. That blue. All around. That blue membrane is fat. And when we clean our dishes, we use soap, like Dawn. Dawn is also used for crude oil spills, save the birds and all that. So when we use these soaps, it breaks apart lipids, fats, greases, oils, separates them. Now, let's talk about the structure of soap real quick. Some of you may have made soap with me in the past. Now, new picture. Soap molecules. They are a hybrid structure. No one really knows where soap came from. We think it's from a hill. There's like this old lore. Those of you who have been in my soap making class before have heard this lore where there's an animal sacrificing hill. There's lots of fires and sacrificing of animals, and the fats eventually mixed with the ashes and rolled downhill to the side of a creek bed where people washed their clothing because it was bubbly water there, because the ash, potash or lye, mixed with the lipid and turned into soap. Saponification through a very basic structure. The lye is base, and then an acidic structure, the lipid. Anyway, moving forward, soap structures. They have a head that's hydrophilic head. It is sympathetic to water. It bonds with water. That's this. I should use a different color. I'll change that. Green. Binds with water. The head of the soap molecule binds with water. And then the hydrophobic tail binds with lipid. Pretty cool. It avoids water and binds with lipid. Water and oil don't mix, right? So, how does this then deal with the virus? Well, it's very interesting, right? So this is our superhero. This is our supervillain. The superhero has the power to destroy the supervillain because of this hybrid structure where we have this funny tail that hooks up with lipids or fats, and this head that hangs out with water but avoids fats. The tail avoids water. So now when we mix soap with water and this virus is present, what happens is the virus acts as like a crowbar. I mean, not the virus acts as, the soap acts as a crowbar and breaks apart the virus. Literally, it just tears it apart. I will show you how. Lipid area, right here. We're just gonna do some of that because now all of a sudden we have the soap molecules, the tail, which binds with fat, finds that lipid structure, that fat structure, that membrane, and binds with it. And then the head that binds with water stays floating around in the water. It's pretty cool. So then we have this going on. And as we're washing our hands, it starts breaking apart the outer structure of the virus. See, we get this really cool thing happening where the fats stick to the fats, the tail sticks to the fats, and then the water pulls the soap molecule away from the virus in many different directions, essentially tearing it apart because the fat is bound to the tail and the head is bound to the water, and the water's moving and flowing. It's not fixed. It's not just like a little thing. It's not a pathogen. It's not the bad guy. It's the good guy. So by washing our hands, that's one step in protecting ourselves from this crazy bug. Yeah? Because the soap absolutely annihilates it. That's really cool. And then when it annihilates it and rips it all apart, eventually it hits the next level. next level looks like this. We got all these soap molecules hanging out, doing their thing. Just la la la. Happy little soap molecules. Bam, bam, bam. And then what it does, it traps the bad guys. So, the dirt and grime and the nasty genetic material gets stuck in the middle. And then maybe even that protein stuff, the way that it sticks to us and then gets us sick, or like, so the genetic material is what gets us sick, and the protein structure is what is a mode of transportation into us. Gets trapped in the soap, and all those molecules, they essentially make a cage around it, and whoosh, with the water it floats away, because what happens? The heads are hanging out with the water, and the tails bind with the fats, essentially making a prison after tearing it apart, and it goes bye-bye. It dies. See you later. Sayonara. It's pretty cool. Yeah, that's what I got about that. Now, questions that we might have is hand sanitizer. We're all sanitizing everything. We're wiping things down, we're spraying them, and blah, blah, blah. Well, really, truth be told, the hand sanitizer does not work as well as good old-fashioned soap. See, we got all this alcohol stuff, and yeah, that kind of works. The bleach water works to a certain level. The hand sanitizer works to a certain level. If it's 60% or more alcohol, it'll work. But it's not as good as a soap. It definitely does destabilize the lipid membrane, otherwise known as melts the fat layer. It's kind of cool. It still kills it. It takes a little longer. You actually have to completely submerge it, and it's not as effective as soap. 20 seconds of hand washing vigorously to really kill that nasty bug. It's pretty cool. It's simple, it's easy. Wash your hands. I touch my face a lot. I also wash my hands. I also hardly ever get sick, although this cold is giving me a runny nose. There was a study done that says that we touch our face as often as every 2.5 minutes. Now, I've probably touched my face more than that. Yeah. A little fun fact, as a foundation of everyday hygiene, hand wash. There was a dude, man. His name was Ingaz Semmelweis. I don't know how to pronounce his name. I don't know his name. But it was a long time ago, like 1840s. A Hungarian guy, a physician. He was a doctor, a professional, way more professional than me. And he discovered that if you were to wash your hands before helping people give birth, women give birth, far less women died. Wow. In the 1840s, they didn't really wash their hands, and people died during childbirth because doctors had dirty hands. Well, he ended up getting ridiculed and eventually got locked up in an insane asylum and got beat up pretty bad. And you know what's really ironic? It really sucks because he was right, but he died from infections from getting beaten. Essentially, he got beat up because they thought he was a quack, insane dude saying wash your hands. And so then they beat him up, and his wounds got dirty and infected, and he died from infections. Wow. That is pretty crazy. Then in the 1800s, Florence Nightingale, that name I could pronounce, was an English nurse. She also said, hey, yo, guys, wash your hands. Your hands are dirty. Clean them. But it wasn't until the 1980s, essentially, that, you know, we were told to wash our hands by the government. Isn't that weird? the CDC, the Center for Disease Control, didn't say or give public regular hand washing protocols until the 1980s. Whoa. Mind-blowing. So washing your hands is a new thing, considering it's only 2020 now. So 1980s was what, 30, 40 years ago? Yeah. That wasn't that long ago, considering humans have been around a long time. So here's the deal, kiddos. We're washing our hands not just because it's a personal protection thing, keeping us safe. It also keeps other people safe, because if we don't wash our hands, we're possibly transmitting it to other people. But washing our hands helps other people stay safe, not just us. I also forgot to mention personal protective equipment, PPE, gloves, masks, eye covering, biohazard bits. Those are all personal protective equipment. Rubber gloves, they're really good so long as you use them right. And just if you put them on and you go out in the world and then you go back to your car and then you're wearing them inside your car, you just essentially just brought whatever you touched in the world into your car. The bottom of your shoes, you're stepping on stuff all the time. You might step on someone's spit. So stepping on like a rag in a baking tray and it has Dawn and hot water or just regular water or even just bleach water and a towel, so you could step in, squish, 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 squish. You just squishy, squishy for a little while, and now you clean and sterilize the bottom of your shoes. That is some of my viral presentation. Fats, virus, pathogens. Hope you all have a wonderful day. Peace, love, and chicken grease. See you guys later.